we'll look at the arc length formula. We use the arc length formula to find the length L of a curve or function on the interval a to b. We can use the arc length formula as long as the derivative f prime is continuous on the interval a to b. The arc length L will be equal to the integral from a to b of the square root of 1 plus the derivative all squared with respect to x. In this example, find the arc length of this function on the closed interval 1/2 to 2. So you don't have to graph the function. Here the graph is just given for reference. And we want to find the arc length, so we want to find the length of the function from 1/2 to 2. So I'll rewrite f of x as x cubed over 6 plus 1/2 x to the minus 1. Then we'll take the derivative for f prime, 3x squared over 6 minus 1/2 x to the minus 2. Then we can simplify by cancelling 3 in the top and bottom. So f prime will become x squared over 2 minus 1 over 2x squared. And next we can use the arc length formula. So we will take the square of f prime. So I'll put it on the side. So here is the derivative squared. Next you can multiply by foiling out the terms. So we have x to the 4 over 4 minus 1/4. Since the x squared and x squared will cancel in the top and bottom, then we have another term of minus 1/4 plus 1 over 4 x to the 4. So now we can plug it into the arc length formula. So with the arc length formula, because of the square root, sometimes it's not immediately obvious how to integrate it. In this case, we can use some algebraic manipulation to rewrite the inside as a square, and then the square and square root will cancel and it becomes integrable. So here we just added the 1 minus 1/2. That became 1/2 in the middle. And next I will factor out 1/4. You don't have to do that if you don't want to. So here we factored out 1/4 from the 3 terms. So we have 1/4 times x to the 4 plus 2 plus 1 over x to the 4. And we can factor x to the 4 plus 2 plus 1 over x to the 4 as x squared plus 1 over x squared all squared. Also, the square root of 1/4 will be 1/2. So then we can rewrite the arc length as 1/2 integral 1/2 to 2 square root of x squared plus 1 over x squared all squared. So the square root and the square will cancel out, and we'll just have the integral of x squared plus 1 over x squared. So we want to integrate x squared plus 1 over x squared. 1 over x squared we'll rewrite as x to the minus 2, and then we can just use the power rule to integrate it. So we have 1/2, integral of x squared is x cubed over 3, and the integral of x to the minus 2 is minus x to the minus 1. So now we'll evaluate it at the upper minus lower limit and calculate the arc length. So here we have 1/2. At upper limit 2, it's 8/3 minus 1/2. Minus, at the lower limit 1/2, it's 1 over 24 minus 2. Then we can add the fractions with common denominator 6 and common denominator 24. And just check that we get 99 over 48. Cancel the common factor of 3 in the top and bottom, and we have 33 over 16 units, which is approximately 2.06 units. And that was the arc length of the function from x is equal to 1/2 to x is equal to 2.